Hi, Assalamualaikum. We are from AS1205M and we would like to present our final project for the subject PHY370. The title for our final project is Palm-based cationic polyurethane membranes for solid polymer electrolytes application, a physico-chemical characteristic studies of chain-extended cationic polyurethane. We consist of three members, which is Muhammad Zahirul Haq bin Zamri, Nazruddin bin Muhammad Nawi, and Muhammad Faris bin Muhammad Zukiman. First of all, polyurethane is a polymer composed of organic units joined by a carbamate links. Polyurethane having a great potential to be used as polymeric host in polymer electrolytes. However, it suffers from low conductivity and high glass transition temperature. Polyurethane was first found by Otto Bayer in 1937. Conventional polyurethane are usually synthesized by a polyaddition reaction between polyols and diisocyanates, which is resulting in a crossing urethane linkage polymer. Nowadays, researchers are striving to replace synthetic polyurethane with bio-based as alternative renewable resources. This is to reduce the sources of petroleum dependency and enhance the biodegradability. So, palm oil was used. Next, we will talk about methodology. Methodology are divided into two, which are preparation of chain extended palm-based polyurethane and the preparation of cationic bio-based polyurethane. For the preparation of chain extended palm-based polyurethane, the polymerization was carried out in a glove box under a nitrogen atmosphere at a constant temperature. Various amount of MDI, PKOP, and PEG were dissolved in THF for an hour in 3 separate flasks before additional polymerization reaction. Later then, the MDI was added to PEG under continuous stirring and left for 2 hours as pre-polymer. The reactions were terminated by the inclusion of PKOP for another hour. Then, the polymerized solutions were cast onto a Teflon dish and left for 24 hours in a glove box at ambient temperature for the curing process. Okay, next is the polymerization of cationic bio-based polyurethane. First, the polymerization of cationic polyurethane also were prepared in PU glove box. The beginning steps are the same as above mentioned before casting and curing process. Iodopropane was added as the last compound to react with all those monomers. The ratios between PU and iodopropane were fixed according to the optimized parameter. Okay, then we will move into results and discussion. First, we will make a physical observation. First, we can see all of the tested material that were prepared turn yellowish in color, flexible, void-free, freestanding, smooth, with the homogeneous surface. For example, in the figure shown, it shows that the presence of different amount of PKOP and PEG gave different tones of yellowish transparent film. The PU3 with the highest composition of PEG was the most flexible and had the lightest yellow color while appearing as a smooth, solid film compared with a sample of lower PEG ratio. Next, we will move to gel permeation chromatography analysis. Gel permeation chromatography, or known as GPC, is a technique for analyzing polymers and for determining the molecular weight distribution and the distribution of molecular mass. The MW, which is the molecular weight, changed as the composition of the hydroxyl group of PKOP and PEG changed by its random interaction during the polymerization process between those monomers. The sample of PU, which is PKOP, had 58% higher MW compared to the PU, which is the PEG. We will move to the fourth observation, which is the Fourier transfer infrared analysis. Fourier transform infrared, or known as FTIR analysis, is a powerful technique to identify the chemical functional groups of polymeric chemical structures. From this FTIR spectrum, the strongest and the most important peaks are shown in the figure below. After that, we will move to X-ray diffraction. X-ray diffraction, or XRD analysis, is used to determine the nature of crystallization in a material. The measurements were conducted at 2 theta in the range of 10 degree to 90 degree. The enhancement in flexibility in the polymeric structure of this modified PU indicates that the modified PU have good potential for use in electrochemical application as reported by others. As seen in the diffraction-gram, all samples are amorphous as indicated by the broad hump centered at 2 theta is equals to 20.45 degree. The hump became more expansive as the amount of PEG increased. PU3 with the highest composition of PEG showed the lowest and the broadest hump at 21.5 degree and showed the lowest TG value as reported in the previous section. Next, we'll move to thermal analysis. The differential scanning calorimeter (DSC) is a powerful tool for thermal analytical characterization of physical properties of polymers. The DSC can demonstrate the properties changes in heat capacity or latent heat and tolerates melting temperature and crystallization temperature. The observation shows that the TG decrease as the composition of PEG with the molecular weight of 200 in the polyurethane system gets higher. Since the TG is a measure of phase transition from rubbery state to a glassy state, this implies that the higher composition of PEG molecular weight 200 can increase the flexibility of the polymer, which aids in increasing ion mobility in the polyurethane. As you can see from the DTG graph in the figure 8b, the first stage of decomposition increased from 160 degrees Celsius to 290 degrees Celsius, revealing that the disruption of the urethane bond resulted in the decomposition of the hard segment. It has been proposed that the 3 decays of urethane bonds might occur simultaneously. 1. Degradation of urethane to isocyanate and alcohol. 2. Formation of primary amine and carbon dioxide. And 3. Formation of secondary amine and carbon dioxide. The conclusion we can get from the figure 8b shows that the thermal degradation for TD1, TD2, and TD3. This demonstrates that all the PU samples are thermally stable up to high temperature. Next is dielectric study. Dielectric properties of the polymer matrix as central to an understanding of ionic conductivity behavior of polymer electrolytes. The dielectric properties of a material can be measured in 2 parts, which the first one is dielectric constant and the second one is dielectric loss. Dielectric constant is a measurement of the stored charge, while dielectric loss is the measurement of energy dissipation in a material. The real and imaginary part of the complex dielectric constant can be calculated using the equations shown. The further study of dielectric is called electric modulus, which was done with the modulus formulation that reflects the relaxation process of the ionic materials. The variation of the real part of the modulus, which Mr, and an imaginary part of modulus, which is Mi, with the frequency at ambient temperature, is shown in the figure 11. It appears that Mr values at lower frequency are minimal and almost near to zero, with the suggest elimination of electrode polarization. The complex modular spectrum for MR and MI is a gauge for the ionic conductivity relaxation. In this investigation, we believe that the primary contribution of the polarization process for all of the materials are mainly from the orientation of the electric dipole from the polymeric functional groups of amines. Only small contribution by the iodide and ions after alkylation reaction. Last but not least is the impedance analysis. The behavior of dielectric materials under the application of steady voltage is mainly dependent on the type of contacts between electrodes and dielectric materials. For symmetrically blocking for electrode contacts, there will be no charge crossing from the dielectric materials to the electrodes and vice versa. Therefore, the transient current observed is due to the polarization of the material, which could be due either to the orientation of electric dipoles or and the movement of positive and negative charges, or both. The ionic conductivity can be calculated using the equation of sigma is equals to T over RB times A, where the sigma is the ionic conductivity, which is the thickness of the membrane film, RB is the bulk resistance, and A is the surface area of the blocking electrode attached. Ionic conductivity can be calculated using the ionic conductivity equation, and all the parameters are summarized in the table below. The result shows that the ionic conductivities of all samples are between 2.28 times 10 to the power of negative 10 S over cm and 2.38 times 10 negative 9 S over cm, which is much higher than the previously reported by Yusuf on 2019. In conclusion, the bio-based PU and cationic PU has successfully been synthesized by the solution casting techniques as a solid film. This film can be appear as a flexible smooth surface film with different range of yellowish tone. The chemical interaction has changed the PU chemical structure and decreases the degree of the crystallinity. The addition of PEG and iodoPropane changed the properties of the materials by increasing the molecular weight, reducing the Tg value, and thermally stable up to 190 degrees Celsius. The sample of PCPU3 achieved with the highest conductivity at 2.38 times 10 power of negative 9 S over cm with the highest dielectric constant, which has an inordinate potential polymeric host to be applied in electrochemical devices. That is all from us. I hope you enjoy and learn few new things from the presentation that was presented, and have a nice day.